July 1947, Detroit. A concrete mixer welded together from junkyard scraps just humiliated every precision-engineered machine on the construction site. The manufacturers spent the next 40 years trying to replicate it, so why did they all fail? Before we continue with the video, if you're listening right now, help me prove something wrong. My wife said I wouldn't even reach 1,000 subscribers, but I believe stories about old machines like this deserve to be heard. Help me show her that these videos matter. Please subscribe to our channel and let's keep these old machines' legacies alive. The laughter started the moment Harold Brennan rolled his homemade concrete mixer onto the Detroit Municipal Airport expansion site on July 12, 1947. Project supervisor Dutch Morrison took one look at the contraption, a mixing drum welded from a salvaged fuel tank mounted on an old Farmall tractor chassis, powered by a diesel engine that had been rejected by 3 different factories, and shook his head in disbelief. "Brennan, that thing looks like it was assembled in a junkyard by a blind man," Morrison said, walking around the machine with undisguised contempt. "This is a professional construction site, not a county fair." Brennan had heard worse. For 6 months, he'd been trying to convince contractors that his design could outperform the sleek, factory-built mixers that dominated post-war construction sites. Every presentation ended the same way: polite rejection followed by recommendations that he stick to his day job as an equipment mechanic for the Michigan Highway Department. The machine sitting before Morrison represented everything the construction industry had been taught to avoid. Its mismatched components violated every principle of modern manufacturing. The mixing drum came from a petroleum transport truck that had rolled over near Flint. The gear assembly incorporated parts from 2 different transmission systems that engineers insisted were incompatible. The drive chain looked like something pulled from agricultural equipment, not precision concrete machinery. But Brennan knew something that the industry experts didn't. He had spent 18 months studying why modern concrete mixers, built with the latest metallurgy and engineering specifications, were failing at alarming rates on Michigan construction projects. The average commercial mixer in 1947 required major repairs every 840 operating hours. Gear assemblies cracked, bearing systems seized, mixing drums developed stress fractures that contaminated concrete with metal particles. Brennan's investigation had revealed a disturbing pattern. The very precision that manufacturers advertised as superior engineering was creating mechanical fragility. Tight tolerances that looked impressive on specification sheets meant that even minor misalignment caused catastrophic wear. Lightweight alloys that reduced shipping costs couldn't withstand the constant vibration and shock loading that concrete mixing demanded. His scrapyard mixer represented the opposite philosophy. Every component had been selected for one criterion: proven durability under abuse. The Farmall tractor chassis had survived 15 years of farm work in conditions that destroyed lesser equipment. The diesel engine, rejected by factories for being overbuilt, delivered consistent power with tolerances loose enough to accommodate wear without failure. The gear assembly, cobbled together from parts that weren't supposed to work together, actually distributed load more effectively than purpose-built transmissions. Morrison circled the machine one more time. "All right, Brennan, you've got 3 days to prove this junk pile can actually work. After that, I want it off my site." Harold Brennan's journey to building the junkyard mixer had begun in October 1945 in the maintenance yard of the Michigan Highway Department, where he'd worked for 11 years. His job was simple: keep concrete mixers running long enough to complete road construction projects across the state. The reality was brutal. Constant repairs, endless parts orders, and machinery that seemed designed to self-destruct. Brennan kept meticulous records in leather-bound notebooks that tracked every repair, every failure, every hour of downtime across the department's fleet of 23 commercial mixers. By early 1946, the pattern was undeniable. The newest mixers, purchased with premium budgets and backed by manufacturer warranties, failed faster than the older equipment they replaced. The consolidated Model 47, advertised as the future of concrete mixing technology, required bearing replacement every 320 hours. The superior Dynamix, featuring revolutionary lightweight construction, developed drum cracks after just 180 hours of operation. The Mitchell Turbo Pour, with its precision German engineering experienced gear failures that stranded construction crews in the middle of critical pours. Brennan began visiting equipment graveyards across Michigan, examining the corpses of failed mixers to understand what killed them. What he discovered contradicted everything modern engineering promoted. The failures weren't random mechanical bad luck. They were systematic design flaws created by manufacturers optimizing for the wrong objectives. Modern mixers were engineered for impressive specifications, high rotation speeds, lightweight portability, efficient fuel consumption, and minimal manufacturing cost. But none of these priorities addressed the fundamental reality of concrete mixing. It was violent, relentless, and punishing to machinery. Every revolution subjected components to shock loading. Every batch created vibration that propagated through every joint and bearing. Every operating hour accumulated stress that precision-machined parts couldn't tolerate. Brennan started sketching his own design in December 1945, working at his kitchen table after his wife and 3 children went to bed. His approach reversed conventional engineering wisdom. Instead of precision, he prioritized forgiveness. Instead of lightweight, he chose mass. Instead of efficiency, he selected resilience. The concept was radical. Build a mixer from components that had already proven they could survive extreme conditions. Farm equipment operated in environments far harsher than construction sites. Mud, dust, temperature extremes, constant vibration, minimal maintenance. Industrial diesel engines rejected by factories for being over-engineered were exactly what concrete mixing needed. Power delivery that continued working even when components wore outside original specifications. Brennan spent his entire savings, $340, purchasing salvaged parts from equipment dealers who thought he was crazy. A Farmall tractor chassis with a cracked engine block, but perfect frame geometry. A fuel tank drum with dents that didn't affect structural integrity. A diesel engine that weighed 140 pounds more than modern equivalents, but had operated continuously for 12,000 hours before its factory rejected it for aesthetic reasons. By June 1947, Brennan's garage contained what looked like mechanical chaos, but represented the most carefully considered concrete mixer design in Michigan. The test began at 6:09 a.m. on July 13, 1947, with 40 construction workers gathered around Brennan's scrapyard mixer, waiting to watch it fail. Dutch Morrison had spread word throughout the Detroit Municipal Airport site that the morning's entertainment would be watching Brennan's junk pile shake itself apart. Brennan ignored the crowd and focused on his startup procedure. Unlike modern mixers with their complex ignition sequences and warm-up requirements, his machine needed only 3 steps. Check fuel, verify drum rotation clearance, start engine. The diesel fired immediately with a deep, resonant rumble that sounded nothing like the high-pitched whine of commercial mixers. Morrison handed Brennan the test specification. Produce 85 cubic yards of 3,500 psi concrete in 3 days, matching the output and quality of the site's 2 consolidated Model 47 mixers. If Brennan's machine could match commercial performance, Morrison would consider it for a contract. If it failed, Brennan would pay for his own tow truck. The first batch revealed why Brennan's design was fundamentally different. Commercial mixers operated at 32 revolutions per minute, creating a violent tumbling action that manufacturers claimed ensured thorough mixing. Brennan's scrapyard mixer turned at just 18 RPM, a speed so slow that several workers laughed out loud. "Brennan, my grandmother churns butter faster than that thing mixes concrete," one operator shouted. But after 14 minutes, exactly the duration Brennan had calculated, the concrete that poured from his mixer had achieved perfect consistency. Morrison personally took samples for compression testing, expecting to find weak, poorly mixed material. The preliminary tests showed 3,620 psi, exceeding specification by 120 points. The real difference emerged as the day progressed. By noon, the 2 commercial mixers had each experienced minor stoppages, a bearing overheating on one machine, a drive belt requiring tension adjustment on the other. Brennan's mixer had operated continuously without intervention, its massive flywheel maintaining steady rotation regardless of load variations. Morrison noticed something else. The commercial mixers vibrated intensely during operation, requiring operators to stand clear to avoid the rattling that shook the entire frame. Brennan's machine barely trembled. Its heavy chassis absorbed vibration before it could propagate through the mechanical system, protecting bearings and gears from the oscillating stress that destroyed lighter equipment. By the end of day one, Brennan had produced 31 cubic yards of concrete, slightly more than each commercial mixer. But his machine had required 0 maintenance interventions, while the consolidated mixers had needed 3 stops for adjustments and minor repairs. Morrison walked over to Brennan as the sun set over the construction site. "I'm not ready to admit you're right," he said quietly, "but I'm starting to wonder if everyone else might be wrong." The next 2 days would answer that question definitively. Day 2 of Brennan's test began with unexpected drama. At 7:23 a.m., one of the consolidated Model 47 mixers experienced catastrophic gear failure, spraying metal shards across the work area and injuring an operator who required 7 stitches. The incident shut down half of Morrison's concrete production and created exactly the situation Brennan had been warning about. Modern mixers engineered for ideal conditions couldn't survive real-world construction chaos. Morrison authorized an emergency inspection of the failed consolidated mixer. The gear assembly, manufactured from hardened steel alloy to precise tolerances, had shattered when a large stone jammed momentarily in the mixing drum. The shock load, lasting perhaps 2 seconds, exceeded the gear's design parameters and caused instant fracture. The manufacturer's engineering manual specifically warned against mixing aggregate larger than specified dimensions, a requirement impossible to enforce on active construction sites. Brennan walked Morrison through his mixer's gear system, explaining why his primitive design actually represented superior engineering for concrete work. Instead of precision-cut gears operating at tight tolerances, Brennan used oversized gears with deliberately loose spacing. When stones jammed or loads spiked, his gears had mechanical clearance to absorb shock without transferring catastrophic stress to the metal itself. "Your modern mixers are like racehorses," Brennan explained. "Beautiful, fast, impressive, and fragile. Mine's a draft horse, ugly, slow, and nearly indestructible." With one commercial mixer destroyed and the other operating alone, Morrison had no choice but to rely on Brennan's machine for the day's concrete production. The scrapyard mixer ran for 11 continuous hours, producing 38 cubic yards of concrete without a single maintenance intervention. Compression tests averaged 3,580 psi with remarkable consistency, less than 40 psi variation between batches. The performance gap became undeniable when Morrison compared maintenance logs. The remaining consolidated mixer required lubrication every 4 hours, belt tension checks every 2 hours, and constant monitoring to prevent overheating. Brennan's machine needed nothing. Its automatic chain oiler distributed lubrication continuously. Its massive flywheel prevented the speed fluctuations that created heat buildup in lighter systems. Its agricultural-grade components tolerated abuse that destroyed precision equipment. By day 3, word had spread beyond the construction site. Engineers from Detroit's largest contractors arrived to examine Brennan's mixer, drawn by reports of a machine that seemed immune to the mechanical failures plaguing their own fleets. They found a design that violated every modern engineering principle and worked better than anything their manufacturers produced. The final test numbers told the complete story. In 3 days, Brennan's scrapyard mixer had produced 94 cubic yards of concrete, exceeding Morrison's requirement by 9 cubic yards. Every batch met specifications. The machine required 0 maintenance interventions and 0 repairs. Total operating cost, $23 in diesel fuel. Morrison offered Brennan a contract on the spot, but by then 5 other contractors were already waiting to talk business. News of Brennan's success at the Detroit Municipal Airport site reached the commercial mixer manufacturers within days, and their response was immediate hostility. In August 1947, Consolidated Industries published a technical bulletin warning contractors about substandard equipment that endangers workers and compromises concrete quality. The bulletin never mentioned Brennan by name, but its description of improvised machinery built from salvaged components made the target obvious. Superior Equipment Corporation sent engineers to examine Brennan's mixer at an Ann Arbor highway project where it was producing concrete for bridge foundations. Their report filed with the American Concrete Institute, acknowledged the machine's adequate performance but emphasized its non-conformance with modern engineering standards and manufacturing quality control protocols. Brennan found himself fighting a battle he hadn't anticipated. His mixer worked better than commercial equipment, cost 73% less to build, and required almost no maintenance, advantages that should have guaranteed market success. Instead, he faced coordinated resistance from an industry that had billions of dollars invested in manufacturing infrastructure designed to produce the very machines his design proved obsolete. The turning point came at the October 1947 National Construction Equipment Conference in Cleveland, where manufacturers unveiled their latest innovations: lighter materials, higher rotation speeds, and advanced precision engineering. Brennan attended as a guest of Dutch Morrison, who insisted that the industry needed to see what actual durability looked like. During the exhibition's open forum, Brennan asked a question that silenced the auditorium. Why are we engineering concrete mixers for ideal conditions that don't exist on construction sites? The response from a Consolidated Industries vice president was telling. Mr. Brennan, modern engineering advances performance through precision. Your approach regresses to crude mechanical simplicity that may work temporarily, but cannot compete with scientific progress. My mixer has now run 1,140 hours without a single repair, Brennan replied. How many of your precision machines can make that claim? The manufacturers had no answer, but they didn't need one. They controlled trade publications, influenced equipment specifications written into construction contracts, and maintained relationships with contractors who bought fleets of commercial mixers on credit terms that Brennan couldn't match. But Brennan had something manufacturers couldn't suppress: operators who had used his mixer and experienced its reliability firsthand. These workers started requesting the Brennan machine specifically on their projects. Contractors noticed that jobs using Brennan's mixer completed faster with fewer delays and lower equipment costs. By December 1947, Brennan had received orders for 18 mixers from contractors across Michigan and Ohio. He was building them in a rented warehouse with 2 assistants, using the same salvaged parts approach that the industry claimed was unprofessional. Each machine cost $840 to build and sold for $2,400, compared to commercial mixers priced at $8,500. The manufacturers were losing market share to a mechanic working out of a warehouse, and their response would prove more desperate than Brennan anticipated. On January 15, 1948, Harold Brennan received a cease and desist letter from Consolidated Industries' legal department, claiming his mixer design infringed on 14 separate patents covering rotating drum concrete mixing apparatus and associated mechanical systems. The lawsuit demanded immediate halt of all production and $127,000 in damages. Brennan had never filed for patent protection. His design used publicly available components assembled in ways he'd developed through mechanical experimentation. But Consolidated's legal strategy wasn't about valid patent claims. It was about burying a small competitor under legal costs he couldn't afford. The lawsuit detailed supposed infringements that ranged from legitimate to absurd. Consolidated claimed patents on drum rotation mechanisms, gear reduction systems, even the concept of mounting a mixer on a chassis. Their legal team had assembled a portfolio of patents broad enough to argue that any concrete mixer violated their intellectual property. Brennan consulted with a Detroit patent attorney who delivered devastating news. Fighting the lawsuit would cost at least $15, money Brennan didn't have. Even if he won, Consolidated could file amended claims and drag the case out for years. The recommended strategy was settlement: accept licensing terms that would make his mixers unprofitable and eliminate him as competition. The offer arrived 2 weeks later. Consolidated would drop the lawsuit if Brennan paid $400 per mixer in licensing fees and agreed to manufacturing limitations that capped his production at 25 units annually. The terms would effectively kill his business while allowing Consolidated to claim they supported small innovators. Brennan was preparing to accept the settlement when he received an unexpected phone call from Marcus Webb, chief engineer at General Construction Corporation, one of the largest contractors in the Midwest. Webb had been following Brennan's legal troubles and had a proposition. Mr. Brennan, I've examined your mixer personally on 3 separate projects, Webb said. It outperforms every commercial machine we own. General Construction will fund your legal defense completely in exchange for exclusive supply rights in 4 states. Webb's company had the resources to fight Consolidated's lawsuit and the motivation to do so. General Construction spent over $2 million annually on concrete mixer purchases and maintenance. If Brennan's design could reduce those costs by even 30%, the investment in his legal defense would pay for itself in months. The trial began in April 1948 and concluded in July with a judgment that shocked the industry. The court found that Consolidated's patents were too broad to be enforceable and that Brennan's specific implementation didn't infringe any valid claims. More importantly, the judge's written opinion criticized attempts by large manufacturers to suppress innovation through frivolous patent litigation. Brennan had won, but the victory revealed something uncomfortable. The construction industry's innovation was controlled by companies more interested in protecting market share than advancing technology. By 1952, Harold Brennan had built 340 mixers, each one assembled, from salvaged components in his expanding Detroit facility. The machines operated across 23 states, and their performance records were creating an embarrassing problem for commercial manufacturers. Brennan's junk pile mixers were outlasting precision-engineered equipment by margins that defied industry expectations. General Construction Corporation tracked performance data across its entire fleet, 89 Brennan mixers and 156 commercial units from various manufacturers. The numbers were devastating for the commercial machines. Brennan's mixers averaged 8,400 hours between major repairs. Commercial mixers averaged 1,200 hours. Maintenance costs for Brennan's machines ran 0.14 per operating hour. Commercial mixers cost 0.89 per hour to maintain. The durability gap created a secondary market that manufacturers couldn't combat. Used Brennan mixers, some with over 10,000 operating hours, sold for more than new commercial equipment. Contractors who had purchased Brennan's machines refused to sell them regardless of offers, treating the mixers as permanent fleet assets rather than depreciating equipment. Manufacturers attempted to reverse engineer Brennan's design, but they consistently failed to replicate his results. The problem wasn't understanding how his mixer worked. The mechanical principles were straightforward. The problem was that Brennan's approach contradicted everything modern manufacturing optimized for. His components were heavy when manufacturers wanted lightweight. His tolerances were loose when precision was industry standard. His parts were mismatched when uniformity streamlined production. Manufacturers could build mixers that looked like Brennan's design, but they couldn't abandon the manufacturing philosophy that made his approach work. By 1958, Brennan had stopped taking new orders. At 61 years old, he had no interest in expanding into mass production. His 340 mixers were still operating, still outlasting everything else on construction sites, still proving that the right engineering philosophy mattered more than the latest manufacturing techniques. The final vindication came in 1973 when the American Society of Mechanical Engineers conducted a comprehensive study of concrete mixer longevity. Of the 50 oldest continuously operating mixers in the United States, 37 were Brennan machines. Some had accumulated over 35,000 operating hours. Engineers examining these machines found wear patterns that indicated they could continue operating for decades more. Manufacturers had spent 26 years trying to build mixers that matched Brennan's durability. They had introduced new alloys, improved manufacturing precision, and developed sophisticated engineering solutions. None of it worked as well as a design philosophy that prioritized forgiveness over precision, mass over efficiency, and proven components over innovative materials. Harold Brennan died in 1981, but his mixers continued operating on construction sites across America. The last confirmed Brennan mixer was retired in 2003 after 55 years of service, a longevity record that modern equipment, with all its advanced engineering and manufacturing sophistication, has never approached. So here's what nobody in the concrete industry wants to answer. If a mechanic working in a warehouse with salvaged parts could build mixers that lasted 50 years, what does that say about everything we've been told about modern engineering progress?